All right, welcome to the second video for 8.1. We're going to talk about simplifying radicals. You would think we just did that, Ms. K. We just simplified radicals, but not every radical is going to go down to a whole number. If you think about it, the square root of 16 is 4. The square root of 25 is 5, right? So I've got the square root of 16 is 4. The square root of 25 is 5. But what about everything in between 16 and 25? Those are not going to end up being whole numbers. You see that? We've already mentioned in the last, in the last video that we don't want any decimals. No decimals at all. So how are we going to simplify this if it's not going to end up to a whole number? Here's the thing about the square root of 24. Its decimal's probably going to be around 4.9, right? It's pretty close over there to... Sorry, just wanted to get rid of that other one. It's pretty close to 25, right? 24 is pretty close to 25, so it's about 4.9. But again, we don't want decimals. Instead, what we want to do is take out anything that would be a whole number. So we're going to piggyback on this factor tree idea from the last video. We're going to go ahead and split up 24. 6 and 4 is what first pops into my head, but it actually doesn't matter. You're more than welcome to use 8 and 3, 2 and 12. Eventually, we'll all get down to the same numbers anyway. All right, so then 6 can break into 3 and 2, 2 and 2, and those are all primes. The only thing I can continue breaking into is that number and 1, and so I could go on forever that way. Now I'm going to look at anything I do have the square of. Okay, so what I have really here is 3 times 2 times 2 times 2. Since this is the square root, I'm going to look at anything I have being doubled. Do I have any number times itself 2 times? Now here I have 2 times itself 3 times, not really what I'm after, but I do have a set of 2 2s, okay? Since I have a set of 2 2s, I'm going to show this to you a couple ways. Technically what I have is a 2 squared here, right? 2 squared. Which means the square is going to cancel the square root. In other words, I can take this 2 out. Just like I took the 5 out of 125, just like I took the 4 out of 16. And so I can take that 2 on the outside. Now the square and the square root are canceling, so it's not 2 squared on the outside, just a whole 2. Stuck underneath, though, is a singleton 3 and another singleton 2, and they don't get to come outside because they didn't have any squares to help cancel that square root. And so we end up squishing them back together to 2 root 6. All right. Some people like to view this as if you have a partner, you get to leave and go outside. I don't know if that's entirely true, but, whatever. Let's do another one here. Square root of 108, let's double check. Is that a square root? I don't believe so, because 100 would be 10, and 144 would be 12, 121 would be 11, but let's try just in case. Yes, I was right. It is not a perfect square, so we're going to have to simplify this one instead. 108, well, 10 and 8 divided by 2 would be 5 and 4, so 54 and 2. Okay, 2's prime, but 54 could be 6 and 9, 3 and 2, 3 and 3. All right, here I actually end up seeing 2 pairs. I see a pair here. Notice the pair is not sitting next to each other, and that's okay. It doesn't have to sit next to each other. And I see a pair of 3's here. And so I'm going to take a pair of 3's out as one singleton 3. Let's write that down. First, let's write down what I have. I have 2 times 2 times 3 times 3 times another 3. This pair, they're both going to get to go outside. I have 2 and a 3, left over 3, and I get 6 root 3 is my final answer. Remember, all of this is multiplying, so we're not going to add those to 5 or anything like that, but we get 6 root 3 as our final simplified form. It's not exactly a whole decimal, right, but it's pretty close. Now you're thinking, Miss K, you just showed us that it's supposed to be 10-something, right, 10.4. Why is 6 root 3 the answer? Well, what's the square root of 3 equal to? The square root of 3 is 1.7, okay? What's 1.7 times 6? Oops, let's put that on the outside, times 6, oops, try again. 1.7 times 6 is the 10.4, okay? So be careful. Don't imagine these as ever multiplying out to what would have been the first number of the decimal form, okay? That's not what's happening here. 1.3 is almost 2. So this is multiplying to almost 2. Okay, be very careful about your radical expressions that way. Don't assume you're wrong. Don't assume you're right based off what you get for the coefficient on these. See, a lot of people mess that up. All right, working a little more with these guys. We've got the square root of 10 here. Let's go ahead and factor tree that bad boy. 5 and 2, both primes can't go any further. Well, now we have a problem, huh? Where's the group of 2? Where is it? Oh no. Here's the thing. This is another one of those simplifying techniques where it doesn't have to work. You just hope it does work. Okay? With any simplifying you ever do, you're hoping that something will simplify out and make your life a little easier, but it's not a guarantee. There are some radicals that just don't simplify. There are some polynomials that just don't factor. There are some fractions that just don't reduce, okay? That welcome to the real world. And so the simplified version of the square root of 10 is the square root of 10, and that's okay. All right, let's build up this idea. We can use higher powers as well. Higher radicals as well. We don't need to do just the square root. Luckily, it's the same exact process. So I'm going to take 16. I'm going to break it into 4 and 4. Careful. Don't jump to the cubed root of 16 being 4. I'm going to break that up 2 and 2, 2 and 2. And I've broken it down to primes. Okay, what we call this is called prime factorization. You can keep, if you are dealing with a square and you see a set that is not primes, like you see a pair that's not primes, you're more than welcome to take those out. But usually you kind of want to go to primes just in case. You kind of want to complete that factor tree all the way down just in case you miss something, okay? Alrighty. Here I have to be careful though. If this was the square root of 16, then I would have 2 groups of 2. The answer would be a whole 4. But this is the cubed root of 16. Meaning if I want to cancel that cubed root, then I need to find a group of 3 things in order for them to cancel each other out. Okay? The cubed root does not cancel a square. The 4th power does not cancel a cubed root. You see that? I have to have cube power, cubed root. 3rd power, 3rd root. They got to match. And so I need a group of 3 here. Okay, I do have that leftover 2, and so what I end up getting is 1 single to 2 on the outside, the cubed root of 2 on the inside. Okay, be very careful this doesn't suddenly change to square. Many people will leave off that index at the end. That would be my simplified version. All right, let's keep going. Let's do it again. 162. Notice the factor tree doesn't change. I just split it up until I get down to primes, right? Let's see, 16 and 2 would be 8 and 1. So 81 times 2. 9 and 9. Careful, I know I see a double, but I'm going to keep going. 3, 3, 3 and 3, because this time I'm looking for groups of 4 that I want to take out. So I'm going to have a 3 on the outside and the 4th root of the extra 2 on the inside. There we are. Okay. I recommend you try this next one on your own with the 6th root here. Yes, the number is quite large, but we're looking for a group of 6. It better be large, right? I'll give you a couple seconds to pause the video and try it on your own. All right, hopefully you got a good pause there. I know that 1458 is even, so what happens when we divide it by 2? 729. That is no longer even, so let's go ahead and divide that by 3. See if we get anything. Yep, 243. Okay. 243. I want to say 7. Nope, just kidding. 3. Okay. And 381. So notice how I didn't know exactly what factors I started off with. I just kept going, dividing by 2 and then dividing by 3, dividing by 3. Now I've got 9 and 9, which is a whole mess of 3s. 1, 2, 3, 4. All right, do I have a group of 6? I have 1, 2, 3, 4, 5, 6. Beautiful. This is going to be 3 times the 6th root of 2. Cool. One last practice one here. We've got 4 and 10, 2 and 2 and 2 and 5. So 2 cubed root of 5 is what I meant to write. Beautiful. All right, now what happens when you already have something on the outside? What happens when there's a 2 sitting in front of this 4th power? Well, basically we ignore it for a little while. Okay, so we're going to focus on the second half of this for a second. divide each of those numbers by 2, we get 3, 2, 4, 0. Let's do 3, 2, 4, and 10. That's a horrible 3. I'm going to rewrite that. And the 10 would become 2 and 5. 324 divided by, I think, 4. Yep, 4 and 81. I'm just messing around with it. I'm not really knowing where I'm going with this. 3, 3, 3, 3, and then 2 and 2. All right, cool. Now, one thing you don't want to do is go back and circle any of the numbers you've already used. Okay, so even though I've got 2 9s, I don't want to circle those 9s. I'm looking for groups of 4. Here's a 4. 1, 2, 3, 4. Very nice. So I have a 3 coming out and a 2 coming out. I have that 2 already there, so I'll just put him there for a minute. And then what's left over, I think, is that 5. Okay, notice how when I take it out, the 2 is already there. Now I've added I've multiplied on another 2 and another 3, and so I get a grand total of 12. If something's already out there, you just tack it on there. Looking good. All right, there's one more video to this one. It's relatively short. It's what to do when you have a variable, and I will see you in the next video to talk about it.